Okay, in this section, let's take a look at limit law. So in limit law, we got phi here. We have the sum, the difference, the constant, the product, the multiple. Let's talk about the constant multiple rule first. The constant multiple rule, I know if you just look at the screenshot, it's a lot of symbol, it's a lot of things to carry, but trust me, you don't need to spend a lot of energy on this. So let's talk about the constant. So the constant multiple, let me just give you an example. So let's say we have limit as x approaches to 10 of 2x. So according to the previous lesson, the first strategy, the basic one, the most basic one to evaluate a limit is you just plug in, right? Can you just plug in? Yes, you plug in the 10. There is no problem at all. The constant multiple rule tells you that when there is a constant, you can simply take the 2 out. So you have limit x approaches to 10 and then x. That's the constant multiple rule. So you just plug in a 10, right? So you have 2 times 10 that is equals to 20. To me, like this rule is sort of like useless. I won't say it's really useless. I will put a quotation mark on the useless because they are really just like common sense. So for this problem, we can also apply the product rule. So we have a limit of one term times another. So another way to write this is you have limit as x approaches to 10, 2 times limit x approaches to 10 of x. So the first limit is always a 2, right? It doesn't matter what x approaches to, we don't care. So 2 is just a 2. And then x approaches to 10, you just plug in a 10, you still get 20, right? So it's useless, but we put a quotation mark on useless. All right, so here is how we do it. The sum and difference are so let's make one right here. So let's say we have limit as x approaches to 5. We have a 2x plus not 5x. I want to use some other number. So let's say x plus 3x. So this, you can rewrite that as the sum of two limits. So x approaches to 5 of 2x and then plus limit x approaches to 5 of 3x. So you just plug in, right? You plug in the 2, you plug in the 3, then you get your 25. So why don't you just plug in the 5 at the beginning? So you don't need to waste 1 minute to write two limits. So that's the rule. So it's, to me, is really just like common sense. So let's try the last one, the quotient. So let's say you have limit x approaches to 5 of 2x divided by 3x. So that is the same thing as limit as x approaches to 5 of 2x divided by limit as x approaches to 5 of 3x. So you plug in the 5, you plug in the 5, but if you plug in the 5 at the very beginning, you get the same thing, right? So to me, this is really just like common sense. All right, so that's the limit law. So let's take a look at the first very simple example. It's a direct substitution. So let's put this thing a little bit up so that gives me more space to show my work. And I want to change colors for my work. So we have two limits. So look at the limits. The first one is a third degree polynomial, right? So you don't see a radical, no square root, no ln, no log. You don't see a fraction, so you don't need to worry about having a 0 in the denominator. Therefore, you just plug in. So for the first one, you plug in 1. So you have 5, 1 to the third, minus 2, 1 square, plus 1 minus 7. All right, so this is just a 5 minus 2 plus 1 minus 7. 4 minus 7 is negative 3. And then the second one, you have a radical, so you have to be careful because the square root of negative, I'm going to write negative, I will just write this starting from now on. So the square root of negative is undefined. So the square root of positive is okay. The square root of 0 is okay, but the square root of negative is undefined. But if you plug in a 5, do you get a negative? No, you're not going to get a negative. So you just plug in a 5. So that is 4 times 5 minus 3. 20 minus 3, you have square root of 17. Yes, you don't need to take out a calculator to approximate this. We are not in algebra class. In calculus, root 17 is root 17. So that is a direct substitution. Direct substitution is not always working. Most of the time, it won't work because no one wants to make the problem that easy. So let's take a look at some not so easy problem. So moving on to the next page, we have some limits to evaluate. So I have 6 problems in here. I want to review 2 very important formulas that you learned in the past. This one is a minus. I type a plus, so I just corrected on my video. So we have to use that in where? In problem 4. All right. You are not going to use that a lot, but it's something that you have to review every time when people study limits. So it doesn't matter where you take this class, your instructor should review this for you because you don't really use that. You don't use that every day, right? So if I ask you to factor a squared minus b squared, you do that every day, but the a to the third minus b to the third, you don't do that every day. So let's take a look at the first one. Number 1, we have limit as x approaches to phi, x squared minus 6x plus phi divided by x minus phi. Obviously, plug in phi is not going to work, right? You plug in a phi, boom, there is a 0 in the denominator. So at this point, we say that at x equals to phi, there is a horizontal asymptote based on the observation we have right now. But we have to do the work to see if that is really a horizontal asymptote. So first, I am going to factor the top. This is a calculus class. You can use any method you like to factor. You don't need to show your work, but not show your work means you don't need to show the little side notes, like show me how you factor the method you use. No, you just write out the result. So that is x minus phi times x minus 1 divided by x minus phi. We have to cancel out the x minus phi. Can we plug in now? Yes, we can plug in now. So phi minus 1 is equals to 4. Is phi still a vertical asymptote? The answer is no. If you graph this in your graphing calculator right now, x equals to phi is not a vertical asymptote. X equals to phi is an open circle. So x equals to phi, later on we will have a very important keyword for this that is called a discontinuity. If you look at the graph, the curve is not going to pass through at x equals to phi. Okay? So moving on to the next one. The next one we have number 2. They all 1 and 2, they look pretty much identical, right? No, I didn't pick an identical problem. I picked that problem for a very important purpose. So we have x approaches to phi, x squared minus 5x plus 6 divided by x minus phi. Yes, we factor because x equals to phi is an enemy. So limit as x approaches to phi, factor the top, you have x minus 2 and x minus 3 divided by x minus 5. Boom, nothing can be simplified. What do we do? Direct plug-in, not working. Algebra, yes, I can do some algebra, but I cannot plug in. So it looks like I am not going to get an answer. By the way, you cannot have a 0 in the denominator. All right, if none of those will work, then we have to check the left limit and the right limit. So first, we let x approaches to phi from the left. That means we pick a number that is slightly, very slightly less than phi. So, but for the top, we are okay. We can just use the phi because the x approaches to phi. We have to investigate that in the denominator. So the top is phi minus 2, phi minus 3. What about the bottom? The bottom, you have a little bit less than phi, minus phi. So think about 4.999 minus phi. What do you have? You have a 0, but you have something slightly less than 0. You don't write negative 0, you write 0 negative. That means on the number line, this 0, the number is a little bit less than 0. It's 0. very close to 0, but a little bit, very, very little bit less than 0. So therefore, the top, you have, did I do something wrong? Yep, minus 3. So the top, you have a 6 divided by 0 minus. So this is like 6 divided by negative 0 point, a little bit less than 0. What happened in here? So when you have that, you have a negative infinity, right? What about the bottom? The bottom, you have a plus, not the bottom. The x approaches to 5 from the right. So you have 5 minus 2, 5 minus 3. So this time you have something a little bit greater than 0. So this is like 6 divided by 0 plus. So you are thinking about 6 divided by this. So that is equals to infinity. Oh, actually, that was my mistake. So this one a little bit less than 0. So what do you have right there? So a little bit less than 0. Then you have negative 0. Okay, switch back to my pen. Negative 0.0001. Because the one I just erased is close to negative 1, right? So this one is close to 0. So you have negative and positive. What is this? So they are not equal. That means, what do you say for this limit? We say that the limit does not exist because the left limit doesn't equal to the right limit. If you take a look at the graph, so when x is equals to 5, we have a vertical asymptote. X equals to 5. For now on, I am going to call that a VA. V stands for vertical, A stands for asymptote, vertical asymptote. So on the right limit, going up to positive infinity, going down. So that is number 2. Let's take a look at number 3. So number 3, we have to go down, but I will copy the problem for you. So in number 3, we have limit as x approaches to 0. We have negative 5 plus x squared minus 25 divided by x. Looks like x is our enemy in the denominator. So the only thing I can do is I fully open up the top. So that is 25 minus 10x plus x squared. And then minus 25 divided by x. So we have the 25 cancel. And then we have to factor out an x. So x approaches to 0. X negative 10 plus x divided by x. You get rid of the x. And then you can plug in the 0. So that is negative 10 plus 0. 0, not 10. That is equals to negative 10. What did we do in the algebra? We just get rid of the x. So when x equals to 0, we have a problem, right? So later on, in another section, I can talk about that right now because the word is not very complicated to understand. So x equals to 0 was supposed to be an enemy, right? Enemy means the function is not continuous. So you have to cut the curve into 2 pieces when x equals to 0. But in this problem, we can do the algebra to remove it. So we call x equals to 0 is a, removable discontinuity. What is removable discontinuity? When you graph, removable discontinuity is like an open circle. It's not a vertical asymptote. If you are unable to remove this, like the previous problem, then that is a vertical asymptote. Trust me, graph this function. You won't see a vertical asymptote. All right. So next one, we have number 4. We have a limit as x approaches to negative 2, x plus 2 divided by x to the third plus a. This, we have to expand the x to the third plus a. So for x to the third plus a, to expand that, that require a strategy called, actually, you know what? we don't need to use that strategy in here. I can just use the formula written on top. So let's don't go back there. So we have a to the third plus b to the third, that is equals to, so we have a plus b times a squared minus ab plus b squared. So a is equals to x, b is equals to 2 because 2 to the third is equal to 8. So this the top, no change. Oh, I did something that people hate, teacher hate a lot, is you don't write the limit. So when you do your homework, it doesn't matter whether you are doing the homework online or you are doing the homework on paper, especially the exams, please start a line with limit. If you don't do so, you will lose point. Even though you do everything online, your teacher won't see your work. If you don't write the limit, the people who read your work, they will hate you a lot, trust me. So we have x plus 2 times x squared minus 2x plus 4. If you don't know, the second factor cannot be factored anymore. There is no way to factor this. Okay, don't even think about it. And then you cancel the top and bottom. So now you can just plug in, right? Oh, when I plug in, I don't need to write limit anymore. So plug in, we have 1. And then this is negative 2 squared minus 2 times negative 2 plus 4. So that means I have 4 plus 4 plus 4, which is a 12. 1 divided by 12. So that is number 4. Moving on to number 5. Number 5 is my favorite exam problem. So when I write an exam, I will try my best to put this problem in there. So number 5, we have limit as x approaches to 0. We have the square root of 9 plus x minus 3 divided by x. All right. So this one, you can't get rid of the x by just do some expansion. In fact, there is no expansion can be done on top. So when you see a square root, most likely you have to use a conjugate. What is a conjugate? Conjugate means opposite sign. So you have to multiply the square root of 9 plus x plus 3. You have to multiply this on top and bottom. Of course, you multiply like this. Okay, so let's go back to orange. So we have limit as x approaches to 0. So the top is 9 plus x minus 9. And then x, the square root of 9 plus x plus 3. So you have 9 minus 9, right? So this one 9 and 9, they are cancelled. So after they are cancelled, you can cancel the x2. Let me just write one more step for you. So limit x approaches to 0, because that's what you came for, right? You want to see me to show my work. 9 plus x plus 3, and then we get rid of the x. So let me use a different color to do that. And then, can you plug in now? Yep, this biggest enemy is eliminated. Plug in. So when x equals to 0, what do you have? Square root of 9 is just a 3. So you have 1 divided by 3 plus 3 is a 6. That is how you do it. So let's try the next one. The next one involves a conjugate. Before we move on to the next one, what did we cancel? We cancel x equals to 0. Is our enemy, a discontinuity. After you cancel it, we call this a removable discontinuity. The last one, what did we cancel? We get rid of the x minus 2, the x minus 2. So that means we call x equals to negative 2 a removable discontinuity. All right, so this word, we will introduce that again when we talk about continuity of a function. But at this point, it is not that hard to understand this word. All right, let's move on to number 6. So after number 6, we have some absolute value to go over. So number 6, orange, number 6, not highlighter. pen. Number 6, so we have limit as x approaches to 0, the square root of 1 plus x minus the square root of 1 minus x divided by x. And if you want, pause the video, write down the conjugate. So assuming you are already done because you paused the video, right? So the conjugate is, we take the opposite sign. So that is 1 plus x plus 1 minus x, 1 plus x plus 1 minus x. And then you multiply. So you multiply the top, you have limit as x approaches to 0. So the top, because of the plus and minus, we can just get rid of the square root. If this one are both minus, then you are unable to get rid of all the square root, all right? I can do it. Oh, by the way, in case you don't remember this red term, what is this called? This is called conjugate. Same thing right here, conjugate. Conjugate means opposite sign. So we have 1 plus x minus, because plus and minus, the two signs in circle, 1 minus x, since that is a minus, so it is very important to use a parenthesis. And then the bottom, you don't need to bother to distribute. 1 plus x plus 1 minus x. What do you have on top? On top, we have 1 minus 1. So the 1 is gone, right? And then we have x minus minus x. So that will be a 2x. So this is a 2x divided by x, parenthesis, the square root of 1 plus x plus the square root of 1 minus x. You get rid of the x, and then you can plug in, right? So our biggest enemy is now removed. And then you plug in 1, so 0. So you have 1 plus 0 plus 1 minus 0. So that is 2 divided by 2. That is equals to 1. So since we get rid of x, and when x is equals to 0, we call this a removable discontinuity. All right, that's how you do it. So this is the end, I believe. Yes, this is the end of this video. So in the next video, I will introduce absolute value.